Hello! Today we're going to talk about a little story about chaos engineering. It's quite easy to understand, so I hope you like it. Let's go! We'll start with a little backstory of Netflix and how it got into the field of chaos engineering. Netflix in the past quarter saw its slowest subscriber growth in many years, much to its stakeholders' dismay. But in the early 2010s, Netflix was a brand new service taking off and dealing with troubles software companies often have with rapid user growth. Early adopters might have been disappointed by buffering, network failures, and unavailable titles. So how did Netflix go from this to an extremely stable system that constantly delivers 4K videos to hundreds of millions of subscribers? Cloud computing. Think for a moment about the changes in our own software systems. 20, 30 years ago, if a hard disk breaks causing our app to fail, we call up Joe from engineering or IT department, have him walk into the server closet and find the disk and then replace it, right? That is ancient history. That's because nowadays our app is made up of tens of microservices running on multiple different data centers 2,000 miles away from each other and operated by a totally different company using storage that runs on a mesh spanning thousands of NAS server blades. That's fantastic progress, man! Back to Netflix. In 2008, they started moving their system to a highly available, highly resilient, and highly scalable cloud-based system. Each one of these advancements comes with additional advancements in fault tolerance to match it, like geo-redundancy, load balancing, auto-scaling, and failovers, and many more. However, like the most modern software system advancements, the increase in power also comes with an increase in complexity and unpredictability. All these fault protections need to be tested and tuned in modern software systems, as Netflix discovered in its early days. While moving to the cloud, Netflix developed a technology called Chaos Monkey, which actually spawned a whole new branch of science called chaos engineering. And chaos engineering is a branch of science investigating what happens to a software system when it encounters an unexpected fault. While traditional forms of testing, unit testing and integration testing, they focus on predictable circumstances and how things are supposed to work. Chaos engineering focuses on how a system responds to the unknown. For example, what will happen to our systems when, say, King Kong steps on the building housing our data center? Or our app goes viral and suddenly we have huge spikes in traffic, bringing our network infrastructure down. Much like other branches of science, chaos is studied by creating a hypothesis, testing it, and comparing the result with a controlled or stable application state. I might say, when network latency increases in each US data center, that traffic will be directed to central US data center. Or I might say, I expect that if I get an unacceptable number of 500 from this microservice, then these people will be paged. All these failovers and safety nets that we assume to work become our hypothesis. Then we use an experiment, tricks our infrastructure into thinking that the fault has happened. Then we record the result. Many tools have been invented since Chaos Monkey that assist in this science. Their main function is to simulate or inject fault into a software system. To do this, a tool is given access to the underlying infrastructure and permissions to run the simulations. For example, taking down a node in a cluster or causing an I/O failure. Tools like Litmus and Chaos Mesh, they both are very powerful and work with Kubernetes platform. There are also dozens of other popular tools and some working with different infrastructure platforms. Regardless of what tools you use, incorporating the practice of chaos engineering when building the infrastructure or making changes to existing architecture may affect its resiliency. Alright, that's it for today. I hope you liked it.